I'll be presenting problem 4. Let me share my screen. Can you guys see it?
Yes.
Okay, so question 4 was called Festival Fund, and basically there are n festivals, and you want to maximize the amount of fun you can have throughout those n festivals. And so basically n is up to 2 times 200,000. So I'll be presenting an n log n solution that can work. And yeah, I think it'll be easier to explain just directly by coding. So I'll first read in the input. And I'll read it in. And then I'll create a class to store the festival start time, ending time, and the amount of fun you can have at that festival. And this problem is a dynamic programming problem that involves sorting. So I'll just implement comparable here so that I can sort the class. So I wrote out the constructors. It'll store the start time, end time, and the amount of fun. And then I'll write a comparator for it.
Wait, shouldn't and equal E?
Yeah. Oops. Basically, I'll explain why we are doing this later in the code, but we are first going to sort by the start time and then by the end time. Oh. That should be right. Okay. And then we're reading the input for the festivals. So I read in the input, and then I'll sort the festivals by their starting time first, and if their starting times are the same, it'll be sorted by the ending times. Once again, I'll explain this when I code the DP. So the DP data will be stored inside of a long array called DP. And basically, DP of I equals the maximum achievable fun within the first I festivals. And please note that this does not consider the festival at index I. It considers all the previous ones. So that may be confusing, but it should become more apparent in the code, in later code. And then I'll just have a long an answer variable. Okay, so basically we need to consider what happens when we use when we go to a festival. So if we go to a festival, then obviously the next festival must have a starting time after the ending time that we just went to. So suppose we went to the festival at index I, then obviously whatever festival you go to next with index greater than I, its starting time has to be greater than the ending time of festival I. So therefore, we loop through all the different festivals, and we consider using the festival at with index A, and then the variable index will store the next possible festival that we can go to, and this is why we sort by the beginning time, because we want the first possible next festival that we can go to. And obviously that'll be the festival with the smallest beginning time that is still greater than the ending time of the festival that we just went to. That's why we first sort by beginning and then we sort by end. This doesn't really explain why we sort by end, but I'll explain that part later. So we'll use the arrays binary search function on F. And then we'll search for the first one that has a greater, whose starting time is greater. And arrays.binary search, I'm pretty sure y'all already know this, but I'll just go through it anyway. So basically, if it can find an element inside of an array, it just returns that index. And otherwise, if it can't find it, then it'll return the index of the first element greater. So if we use the binary search function, it'll return the index of the first element greater than this festival that I created. But if you analyze this closely, you realize that these two represent the variables end and fun, and end and fun can only go up to like 1 million. So obviously if these are a billion, and if these are 2 billion, then obviously it'll be greater than any festival with an starting time of f of a.n. Therefore, this will return the index of the first element whose starting time is greater than f of a.n. And oh yeah, something I forgot to mention, like if it doesn't find it, it returns that index, but it returns it in the form such that you need to retrieve the index by doing this. It basically returns index, the negative of the index plus 1, and it'll be shown as negative, and then you just do this, and then you get the index you want. Okay, and this part shows why we sort by last second after we sort by the starting time, because this ending time we need to be after all the festivals with starting time FFA.end. Therefore, we need to sort by n after. And yeah. Then we continue. So if index is equal to n, that means like basically we've gone to all the festivals we could possibly go to, and then we'll update the answer with that value. With the amount of fun we can have. And otherwise, we can still go to more, and then we'll store the value at DP index. And if A is not equal to the last index that we look at, then dp of A plus 1 equals math.max dp of A plus 1 dp of A. And this is because like if DP is still an achievable fun within the first I festivals, but obviously if you can't achieve it within the first I festivals, you can still achieve it by within the first I plus 1 festivals. So you need to update it for DPA plus 1. Yeah, and then you just print out the answer. Yeah, this should be right. Oh, bro. Okay. Why is this wrong? Long array cannot. Oh yeah. Oops. Okay, that should solve all these errors. All right. Oh, oof. Oh yeah, I forgot to throw IO exception. Yeah. Okay, now it should be good. Okay, yeah, it's all accepted. And that concludes the solution.